So now we're going to look at an example. It's taken from the book Harris McCaffer, Modern Construction Management, the 7th edition, and it's on page 99 if you want to work or look at it yourself. So the question is we've been asked to prepare a line of balance schedule for the construction of 20 houses using the information provided in table 1 below. Just a few notes on the question. So the operations are sequential, which means they go one after each other. The total number of houses is 20. The target rate of build is 3 per week. This could be represented by the letter or, where 1 week comprises of 5 8-hour days and there's a minimum buffer between activities of 5 days. So we have been given this information here in table 1. So first column is the activity or the operation. So this is a description of what's going on. Sometimes that's just going to be a letter like A, B, C or D, or you might have actually a more detailed one. So here we've got a combination. So it's activity A, substructure, activity B, superstructure, and so on. The second column is actually the labor hours per operative. So this is how many people are going to be working on it. This is how many hours they're going to be putting in. So you'll see on our third column, the optimum number of operatives per activity is 3. So this means that each one of these operatives are going to be putting in 110 hours in order to get the substructure complete. And the same follows for the other activities. So the way we're going to look at this, first of all, we're actually going to use Excel for this example. So let's just switch over to the spreadsheet. So in the spreadsheet here, basically all I've done is actually I've brought the information in from the question, just inserted it into Excel. So again, we have our activities in the column here, our labor hours per activity in this column, and our operatives per activity. The only thing I've actually added is I've numbered the columns up the top here. So I've got column 1, 2, and 3. So this will just make things a little bit easier later on when I'm explaining. And then down the bottom, I've actually just put in cells for the extra information that we were giving in the question. So the total number of houses, the target rate, the length of the day, and so on and so forth. And the buffer as well, so this can be very important. So once you've actually want to start this question, what we should do next is actually expand this table. So we've only got 3 columns at the moment, but we're going to expand this out to 9 columns. So I'll just show you what I mean. I'll just unhide it here. So here are our 9 columns. So column 4 is now going to be entitled the theoretical gang size of the chosen output of rate of ore. So the gang size in this case is the team of people working on the activity. The actual gang size is something we're going to calculate in a few steps. Then the actual rate of output is in column 6. The time in days for one activity is in column 7. The time from start on the first unit to the start on the last unit is in column 8. And then I've actually just put in a table here, or a column here for the minimum buffer time, because we're going to be using that number throughout the calculations. So let's get started. So there's a few different steps involved in completing the line of balance. So I'll just bring up the formulas here in the step-by-step guide. So I've just brought up the notes here on how to complete this. So the solution for completing a line of balance, let me say, is step 1, we're going to fill in column 7. So this is determining the days, determine the time in days for one activity. So you'll notice actually we don't actually fill these in I suppose a logical order like column 4, 5, 6 or 7. We have to kind of jump back and forth between some of the columns. So we're going to start off in column 7. So this is here. So time in days for one activity. So the formula for working out this is the labor hours per operative divided by the optimum number of operatives per activity multiplied by the length of the working day. So again, I'm just going to be using basic Excel. I won't be explaining how Excel works. So hopefully you know what I'm doing. But we'll just get started. So it's equal to labor hours per operative. So this is actually just the number here in column 2. And that's going to be divided by the optimum number of operatives per activity multiplied by the length of the working day. So this is going to be, length of the working day is 8 hours, which was given in the question. Close brackets. And now because we can actually do this in Excel, we're going to fill out this formula here and then copy it down. Because we're going to copy down, when we're using any numbers from this table down here, we want to make sure the cells are absolute so we don't change them as we're going along. So we're going to highlight the cell C19, which is the length of the day, and just press F4 on the keyboard. That'll just make it absolute. And then we'll just hit enter. And that's giving us a number of 4.58 days. So we'll just copy this down for the other activities. And we'll see now we've gotten 4.85 days. This is the time in days for one activity based on the labor hours per activity and the operatives per activity and the length of the working day. So, 4.58 days to complete the substructure, 5 days to complete the superstructure, 5.07 days to complete the joinery, and so on and so forth for the plumbing and finishing. So that's our first step done. So the next thing we need to do is going to fill in column 4, which is determine the theoretical gang size. So this is going to be our labour hours per operative divided or multiplied by the target rate divided by the number of working days per week multiplied by the length of the working day. So we'll just go straight away. So again, we're going to be starting in activity A and just copying the numbers down. So again, so it's labour hours per operative, so it's going to be 110 for this example. So we have the labour hours per operative. We're going to multiply that by the target rate, which is going to be 3 houses. And again, we're using the number from this little section down here, so we want to make that absolute, because we're going to copy it down, we don't want the cell to move. So F4 to make that absolute. And just to be sure, we'll just put this in brackets and we'll divide that by the number of working days per week, which is going to be 5 working days multiplied by the length of the working day, which is going to be 8. Close bracket, and again, both of these are going to be absolute because we don't want them to change because they're going to stay the same for every question, or for every activity, I should say. So again, just highlighting and press F4, hit enter. So this is giving us a theoretical gang size of 8.25. So that's the amount of people that is going to be needed to complete the superstructure or the substructure based on all the labour hours per activity, the target rate and the working days and the length of the days. So we'll copy this one down again. So you can see then, for the superstructure it's going to take theoretical gang size of 24, the joinery is going to be a theoretical gang size of 27.38, and the next one is 2.63, and the finishes is going to be 15.75. So now we've actually calculated the theoretical gang size. Obviously then we're going to actually determine the actual gang size. So obviously in a theoretical gang size, for example, we can't have 8.25 people because that might be quite uncomfortable for some. So what we're going to do is we're actually going to bring this up to our whole number. So you can see in the notes, step 3 is the next one. So fill in column 5 is the actual gang size. So we're going to use this one here. So it's actually going to be rounding up the theoretical gang size to a multiple of the number in column 3. So this is where we're going to play around the numbers a little bit first of all. So just before we get started, what I'm going to do here, these little cells here, these are actually just going to show how we're going to come up with this actual gang size number. But first thing I'm going to do, I'm actually going to, into this cell here, I'm going to copy the operatives per activity, just these numbers into each one of these cells. So I'm going to just type them in because I want to keep the grey formatting, so you'll see they're not part of the actual calculations later on. So now we need to think of what we're going to multiply each one of these numbers, so the operatives per activity, what we're going to multiply them by, so we actually get a number that's going to be close to the theoretical gang size, but also a factor of the operatives per activity. So in this case, some of them are going to be straightforward enough. So the theoretical gang size here is going to be 8.25. So what are we going to multiply by the operatives per activity, which is 3, to get close to 8.5? Well, obviously, if we multiply it by 3, that's going to give us, let's put the formula in then, so equals that guy by that. That's going to be 9. So now our actual gang size, we basically rounded it up to 9 people, because obviously it's a whole number, and 9 is a multiple of the number in column 3, so the multiple of operatives per activity. So then we'll do the same for the next one. So this was going to be a little bit easier. So we have the theoretical gang size is 24. Now looking for us the operatives per activity, which is going to be 8, is actually a multiple of 24. So just again to show how we're going to do it, it's going to be 8 by 3, and then we can just copy the formula. Actually, we can copy down the whole way, and we'll fill these out as we're going along. So if we multiply the operatives per activity by 3, that'll give us 24 as an actual gang size. And again, that's lucky it matches the theoretical gang size, and because it's a whole number, we don't have to chop any body parts off to make them fit. So the next one we're going to do is 9. So we'll see here in the operatives per activity we've got 9. The theoretical gang size is 27.38. So we're going to multiply this 9 by a number to kind of get as close to 27.38 as we can. So obviously there's 2 options here. If we multiply it by 3, we're going to have, it's obviously going to give us 27. Now that's obviously fairly close. But now if we went to 4, that would actually end up giving us 36, which is probably a bit too much. And if we go down by 2, it's going to be 18, which is going to be a bit too little. So 27, even though the theoretical gang size is just a little bit over, 27 is close enough, so we're happy with this. For the plumbing, you see our operatives per activity is 2. So again, in this case, we just need to stick a number in here that's going to be a multiple of 2. And that's going to be as close to 2.63. So obviously we could multiply it by 1, but then we'd be 0.63 off. So maybe better have a little bit more in this case. So if we multiply 2 by 2 here, that'll give us 4. So the actual gang size is 4. So and 4 is obviously a multiple of the number of operatives. So the final one then is going to be the finishing. So again, we have 15.75. We have a 5 here. So just a bit logical thinking. So if you multiply the 5 by 3, that'll give us 15. And that's pretty close we're going to get to the actual theoretical gang size. If we multiply it by 4, it'd be at 20. If we multiply it by 2, it'd be at 10. So 15 is just the closest number we can get. So again, these are grayed out because we're not going to use them in calculations, but we'll use these numbers later on. So that's our step 3, filling in the column 5 and determining the actual gang size. So the next step is step 4. So we're going to look at filling in column 6, and that's determining the actual rate of output. So the actual gang size, that's going to be calculated by having the actual gang size multiplied by the number of working days per week multiplied by the length of the working days, and that's all going to be divided by the hours per activity. So let's go in. So we're in column 6, so the actual rate of output. So again, we'll just start off with activity A, and we can just copy it down once we know it's working. So actual gang size, which we worked out, is 9. And that's going to be multiplied by the number of working days per week. So that is going to be 5. And again, that is absolute because we're taking it from the table down here. So we'll just put it in as we're going along. So then number of days per week, and that's going to be multiplied then by the length of the working day, which is going to be 8 hours. And again, we want to make that 8 hours absolute. So that's all the top half of the formula. So I'm just going to put all that in brackets just to make it stand out for everybody a little better. So that's obviously and then that's going to be divided by the hours per activity, which is given here in column C. So this is one of the bit of information we were actually given. So in this case, for activity A, it's just going to be cell C5 or the 110. So now we have our formula here. So that's basically our actual gang size multiplied by the number of working days multiplied by the length of the working day divided by our hours per activity. You can see them all highlighted in the cell. So we'll just hit enter. And that's going to give us an actual rate of output of 3.27 units, or 27 houses in this case. So we can copy that down, and then we get the same thing. So activity A, we're going to have a rate of 3.27. The activity B is going to be a rate of 3, 2.96 for C, and so on and so forth. Okay, so we're getting there, we're flying through this. So step 5 is to fill in column 8, so determine the time from start on first unit to start on last unit. So again, think about this logically. So how many days are between starting on house 1 and starting on the last house, number 20? So i.e. that means like 19 houses are being completed. So what's just the time difference? So again, there's a formula for working this out. So it's the number of working days per week multiplied by the total number of houses minus 1 divided by the actual rate of output. So we'll throw it in here. So we'll just go into column 8 and we'll work this out. So we have, it is going to be the number of working days per week. So it's going to be 5, but obviously that's already going to be absolute because it's from the formula down there and we want it to be the same for each one. So it's going to be 5 working days multiplied by the total number of houses. So I'm just going to put this in the little formula again just to make it stand out a little better for everybody. So total number of houses. So again, we're talking about the starting on the last unit. So that means having 19 houses completed. So we have 20 houses altogether, and we're just going to, we'll use the formula instead of just typing it in. So the total number of houses minus 1. And again, in this case, because we're using that from the information down there, we're going to make it absolute. I'm going to close the bracket there, and then we're going to divide all of that by the actual rate of output, which is the number we worked out previously. So this is in column 6. So here we have our formula, which we have the length of the working week multiplied by the total number of houses minus 1 divided by the actual rate of output, which we calculated in step 4. So we'll just hit enter. So that's giving us a number of 29.03. And again, we can copy all this down. So there we go. And then the last thing, well, we don't actually work this out. I'll just maximize the notes because we don't need the notes there now for the moment. So we'll just make it a bit bigger for everybody. Okay, so we have now our table mostly complete. The only thing we need to put in here, which is, technically this is actually given down in the table here, but this will make things a little bit easier later on. So we're just going to put in the buffer time for each of the activities. So here we have our completed table. Again, the grayed out ones are just for explaining where we came up with the numbers, but this is where actually the first phase of the line of balance schedule comes from. So we're going to use this information next to develop another set of information. So we're going to develop the points that are going to be used for actually plotting the line of balance chart. So hopefully you've worked along with all this and hopefully your numbers are all correct. So let's go on to the next part now. So for the next phase of the line of balance schedule, we have to kind of just add on another little bit of table. So let me just zoom out. So I have it actually hidden here. So I'll just unhide these cells. So this was our part 1 of the line of balance. So we need all this information. This is going to determine some factors, and this information is going to be used then to determine the points on which we're going to plot our line of balance schedule on the graph. So as I said, all this data will be used to derive the points needed for our line of balance diagram. And then once we've got all the data points done, then we'll actually start plotting it. So let's get started. Okay, so we have our options here, so our details here. So we have this table here, so we're going to create a new one. So we have a column here for activity operations. This is going to be the same as we have here. So for this one though, I'm actually just to save a bit of space, I'm actually just going to put in the capital letters. So we have A, B, C, D, and E. And again, just to make it look a bit nicer. So there we go. So the next thing we're going to look at is first thing we have to look at, we'll start with activity A. Unfortunately for this one, you can't really carry down, it's not really good practice to carry down the calculations like we carry down here. It's not going to work. We dragged all the formulas down. So we're going to have to kind of go through each one of these cells individually, work them out as we go, but follow along with me and hopefully it'll make a little bit of sense. So obviously the start day for unit 1, as again, it's going to be starting on the very first day. So in this case, it's going to be starting on day 0. Let me just make all this cell. There we go. Okay, so that's starting on day 0. So that's all going to be your activity, your start day for unit 1 is also going to be starting on day 0. So the next we're going to look at is going to be our end day for unit. And again, for this one, instead of actually just typing in the numbers, I want to actually just reference the cells from this information here and down here. So the end day for unit 1, but if you think about it logically, this is our activity 1. So when we're talking about unit 1, it's actually more or less talking about the activity. So just be careful you don't get too confused. It's not talking about completing the full house, it's actually just completing this activity. So the end day for unit 1 or activity 1, the substructure. So we know our substructure, we've actually calculated out in this previous example, in the previous part, the time days to complete one activity is going to be 4.58. So obviously if the activity is going to be completed in 4.58 days, that's going to be the end day for this activity. So we're just going to equals, and this cell here, so it's going to be equal K5. So we see it's going to be 4.58. So the next we're going to look at is the last unit or the last activity. And again, in this case, we actually have it worked out. So if we go back to our table, you'll see here, we've actually have the number, it's called the time from start on first unit to start on last unit, which is actually what we have here, the start on last unit. So again, we'll just equals cell here, we'll start 29.03. And now we're going to think about it here, we're going to finish the last unit. So if you think about this, what do you think? It's going to be, if the last unit's going to start on day 29.03, when do we think when the last unit going to be finished, or the last activity going to be finished? Well, if you think about it logically, we've already kind of worked out the numbers here. So if this is going to be, it's obviously going to be the start day, which is going to be the 29.03, and then the duration of whatever the activity is. So again, the time and days for activity 1 is 4.58, so it's just going to be the start day, the start last unit, plus the end day for unit, or the duration. So I'll just take the reference cell over here. I'm sorry, that didn't go exactly what I wanted to do. So it's going to be that plus, so it's going to be the start last unit plus the duration of the activity. We hit enter. So that means activity A, the substructure, is going to be finished for everything on day 33.61. Okay, so now we'll go down to activity B. So in this case, it's going to be, again, similar enough. So if you think about start day for unit 1, or activity 1 for unit B, so B actually can't start until A is finished, or till A is started. So A is going to be starting on day 0. So obviously now we know activity A is going to start on day 0, and it's going to take 4.58 days. So that's going to be the time. But we also know there's actually going to be a minimum buffer time of 5 days between activities. That's just again so we don't actually overlap and people aren't going to be sitting around the building site doing nothing. So the start day for activity B is going to be the time from the activity A, so that's how long it's going to take activity A to finish, plus the buffer time, because there's going to be a 5-day buffer time between the two of them. Hit enter and we got 9.58. So the next thing we're going to look at is going to be the end day for unit 1. So this is going to be start day, and again it's going to be a 5-day buffer between the different activities. So I'm just going to add in the buffer time again. So that 5, and that's going to give us 14.58. And then starting the last unit, so this is going to be in this cell here. So here we have, it's going to be equals the start day for the first unit of activity B, and then it's going to be plus the actual time from start on the first unit to start on the last unit, which is 31.67. So I click that cell, hit enter, and that's going to give us 41.25. And again, we're going to finish this unit. So again, you can think of the logic like the first one. We're going to start the last unit on day 41.25. When's it going to finish? Well, all we do go back to this table over here, and we'll see that the duration of the activity is going to be 5 days. So it's just going to be the time to start. We start on the last unit plus the 5-day duration that it takes to complete substructure or activity B. That's going to give us 46.25. Okay, so we're going down now to activity C. So activity C, obviously activity C can't start the start of activity C until activity B is finished at the start. So in this case, we're going to be using the actual end day for unit 1. So once the end day for unit 1 has actually come and gone, so that's our 14.58. So we're going to use this number. And remember, there's going to be a 5-day buffer between the activities. So again, activity B ends on day 14.58. So that's the earliest our activity here can start, but there's going to be a 5-day buffer between activities as stated by the question. So we're going to add in the 5-day buffer, and that's going to give us 19.58. And then to work out the duration, or the end day for the activity, it's going to be again the start day plus the actual duration. So if we go across to the table here, the time and days for this activity is 5.07. That's going to give us an answer of 24.65. Now we're going to go back again to just the day. We're going to calculate the day. It's going to be working on the last unit. So the last unit then, the last unit for activity C. So it's going to be equals, So obviously it's gonna be the start date. The activity C is gonna be starting until 19.58, day 19.58. And then we're gonna add the number here, so 32.11. So this is the time from start on first unit to start on the last unit. So it's basically just this is the total time for the activity, as we mentioned here, plus the actual day we're going to start on. Oops, we don't need that. That's going to give us 51.69. And again, to finish the last unit, it's just going to be 51.69 plus the actual duration of the activity, which is 5.07. So that's going to give us 56.73. So that's the day when the last unit of activity C will be done. And again, like the previous example or the previous activity, so we're going to look at when the start of activity D can do. So obviously activity D can't complete, the start of activity D can't happen until activity C is finished. So activity C is going to finish for the first one on day 24.65, and then it's going to be this plus the actual buffer time, because remember it's going to be a 5-day buffer. So if activity C for the first unit finishes at day 24, and then there's going to be a 5-day buffer, we're just going to add on the buffer here. That means activity D can start on day 29.65. So now we're going to look at the end date for unit 1. And again, like the previous example, it's just going to be the actual start day plus the actual duration we calculated, so the time in days in terms of activity for the activity. So it's going to be the 29.65 plus the 2.19. That's going to give us an answer of 31.84. So now we're going to look at the start for the last unit. So since the problem was with the start time, so we're actually going to just go back to here. So starting in the start time for the last unit, so we're going to equal, so we know basically activity C is going to be finished on day 56.76. So we're going to equal that. So it's going to be this number. Then we're going to add that. Oops, sorry, just something happened there. So we'll try that again. So it's going to be the 56. So obviously activity C finished on day 56.76. So to get the actual new start time for the unit for the activity D, we're going to get the time the activity C is finished on. We're going to add a buffer time because that's actually what the buffer is for. So if there is going to be a clash, then we can just add on an extra bit of buffer to kind of spread out the activity a little bit. So we're going to add on the activity, actually we'll add on the one from D here. It's going to keep it logical. So that's going to give us a number of 61.76, that's good. So now basically our activity D, the last unit is going to be starting after activity C. So we're actually already on the right path now. So now to work out the start day for activity D for the first unit, we're actually going to be using this number here, the 61.76. That's the day we're going to have to just work backwards compared to the other one. So we know the last unit is going to start on day 61.76. So now if we use that and then take away the number we have here from column A, which is the time from the start on the first unit start on the last unit, if we take that away, that'll actually tell us when activity D can now start in a way that's not going to affect activity C. So again, the buffer is going to be delayed a lot longer, but it just means that the activities aren't going to be bumping into each other. And again, this is going to be the same as the previous example. So the end day for unit 1 is just going to be the start day plus the duration for that activity. So it's going to be the 2.19. It's going to be a 43 point. That's correct. No, 2 seconds now. Yeah, sorry, correct. So that's going to be exactly. So that's going to be let's cover that again. So the start day is obviously 40.98. So again, like the previous examples up here, it's going to be the start day plus the duration. That's going to be when it's going to end. The first unit's going to end. So now all we need to do is actually calculate the time for the last unit, which again, straightforward enough. We have the start time, which is going to be 61.76. Just add on the actual duration for one activity. Sorry, this didn't work out. So it's going to be this plus the duration of the activity. That's going to give us 63.95. So I just highlighted those in green because these are the ones we had to change. So again, now finally going to activity E. And again, like the previous examples, bar D. So activity E is going to start whenever D is finished. So activity E, the first unit can start once the activity D's first unit is complete. So we have our day time is going to be 43.17. That's when the first unit is going to be completed for activity D. But remember, there's going to be a buffer of 5 days between activities. So we're going to add on the 5 for E. That's going to give us 48.17. The end day for unit 1 is obviously just going to be the start day plus the duration of the activity, which is 5.25. Gives us 53.42. The start of the last unit, again, same as what we did in the previous example, in the previous activities. So it's going to be the start day. There we are. Start day plus the actual time from the start in the first unit to start in the last unit. It's going to be 81.42. And again, nice easy one to finish. The last unit's going to be finished. So the last unit starts on day 81.42. So it's going to finish on obviously the start day plus the actual duration. So it's going to be 5.25 here. Then we have 86.67. It's going to be our final day. So that was a slightly little bit complicated, but it's kind of a long-winded process. But that's how we actually derive the points for our line of balance. So now we're actually going to use each one of these to actually plot our chart. So we can start that now. Okay, so the last thing we did in the Excel file was actually derive the points for the line of balance diagram. So I've just brought that table over here into OneNote, and we'll just draw the actual diagram now. So one of the first things we're going to do on the x-axis, we're going to have the actual duration. So that's the time of the activities in days. And on the y-axis going up, it's going to be the number of units. So we'll see on activity E. Activity E ends on day 86.67. So we're going to round up to 90. So we'll just draw an x-axis up to 90 again. Just doesn't matter about size or scale. You can whatever you want as long as it's kind of evenly divided. So let's draw one here. So we'll start off with, it's going to be 0. So obviously the time actually starts on day 0, and then we'll just mark in that it's going to be 10, 20, 30, 40, 50, 60, 70, 80, and 90. So just mark these in. And again, this is days. If you're drawing any graphs or any charts, always put in your units on the axis, otherwise it's no good. So on the y-axis, we're going to go up to 20. Again, you don't have to be matching scale, so just pick something that's roughly, so I'm just going to pick something that's going to fit on the page. So now I'm just going to draw the y-axis, so we're going to go up to 20 here. So again, the scale doesn't have to match the axis, the x-axis, so as long as it's evenly divided, you should be okay. So I'll go back there, it'll be 20, 15, 10, 5. Sure, I'll just mark the other ones just so a bit more evenly spaced out. Okay, so I'll just fill in the numbers. So it's going to be 5, 10, 15, and 20. So this is going to be the units going up like this. Okay, so next thing we're going to do, okay, so we'll start off, we'll just do activity A first of all, and I'll just do it in a nice blue colour, make it stand out. So we're just going to mark the points on the chart first of all. So start day is going to be day 0, which is going to be down here. The end day for unit 1 is going to be 4.58. Again, if you're not using graph paper, you have to use your best judgment, so it's going to be somewhere here. Tick them off as we're going along. The start of the last unit is going to be day 29.03. So you can use your best guess or your best judgment. So it's going to be roughly about there. And then the finish of the last unit is going to be 33.61. So we'll say maybe somewhere about here. That should be down a little bit lower. So now we've got our 4 points for activity A. Now the way we actually join those up together is we just join the start and finish times from activity from the first and last units together. Like this. And we can write activity A. So that's where activity A is going to look like. Now we'll do activity B. So we'll go green this time. So activity B is going to be the first, going to be 9.58. So just on the other side at the 10. And let's mark it off there. And the end time for a unit is going to be 14.58. So again, somewhere around here. Tick off. Then the last unit is going to be 41.25. So again, going up is going to be about there. And then it's going to be 46.25. So just over the halfway mark. So somewhere there. And then again, same thing again, we're just going to join the dots up. Just to show activity B. So this is B. Okay, so we'll do C next. We'll pick another color. We'll go orange this time. So C is going to start on 19.58, so it's just before the 20, so somewhere there. I'm going to end the first unit is going to end on 24.65, so somewhere about there. So again, tick them off as we're going along. The last unit is going to be 51.69, so we're going to be a bit of a jump. So 51.69 is going to be, that's the start, the last unit, and the next one is going to be 56.76, so about there. Yeah, we'll join up the dots. So we have C. Okay, just tick them off as we're going along. So we can ignore the D's in red. So we'll just move on to our corrected version of the D. If we had actually drawn that D, I'll show you roughly, I know from this roughly what it looked like. If we had done that D without actually applying that correction, what would have happened is that the start would have been fine, but the top of it would have actually ended up going somewhere like that. That means obviously activity C and D are going to be clashing with each other, which we didn't want, so that's why we applied those corrections. So our new D values are going to be, start time for unit 1 is going to be 40.98. So say roughly here. So we see we've added quite a nice big buffer here. So 40.98, and then it's going to be 43.17. So it's going to be quite close together. And the end is going to be 61. So about here, and then 63.95 is going to be quite close again. But now we can see that it's actually not going to be clashing because we applied that little fix when we were doing it in Excel. So that is D. So we'll just tick all those guys off. And the last one, we'll go for do pink. So activity E is 48.17. So say roughly somewhere there, and then that's the start unit, and then the end for unit 1 is going to be 53.42. So about there, and then it's going to go up to 81.42 for the start of the last unit. somewhere there. And then the last unit is going to finish on 86.67. So again, you can't see. I actually have a ruler on the screen here, kind of positioning these correctly, so I'm not completely guessing where they are. So hopefully if you're using your ruler or you've got graph paper, you can do this nice and accurately. So here we have our activity E. So this is basically our line of balance diagram now complete. So we are just tick off everything, that make sure we've corrected everything we needed. So we have our diagram here, so just kind of explain a few little things. So obviously the distance between each one of our activities, so these distance here, that's your duration of the activity, which we calculated in the first part of the exercise. Again, this distance here from the start of the graph to here, that's the distance space between the start of the first unit and the start of the last unit. So start of unit 1 and start last unit. So that's what that distance is. And again, just to kind of, if you haven't followed exactly yet, so our points here, so this is our start unit 1, start day unit 1. This point here is going to be end day unit 1. And up the top here we have our start last unit, and here we have our finish last unit. So that's basically what we're plotting. We're basically plotting the start days for the start and the end day for the first unit, and the start and the end days for the last units, and you get a graph looking like this. So this is how we actually work our line of balance. So this will actually help us identify if there's actually any clashes. And again, it just makes things easier because we don't want kind of scheduling people on working sites. If there's going to be clashes between activities, then there's going to be people sitting around doing nothing. That's going to be wasting money on the project. So doing things for line of balance, doing the line of balance will help eliminate any of those errors that could occur. So that's all we're going to cover for this line of balance example. Hopefully it made sense. If not, just go back and watch the videos. Again, there's notes online on Brightspace that'll help you along. And if any questions, just send me an email and I'll get back to you as soon as I can. Okay, thank you.